Okay, good day. Welcome to our recorded video. So our topic today is about sigma notation. So at the end of this lesson, the student is able to use the sigma notation to represent a series. Aside from that, we will do expansion and evaluation of a sigma notation. So for topic outline, we will define and write the sigma notation, evaluate the common sums or the simplest sum written in sigma notation. Then we will discuss the properties of sigma notation for us to solve easier and evaluate the sum written in sigma notation more fast. Then we will calculate sums using the properties of sigma notation. So what is sigma notation? So sigma notation is also have a term summation notation. So it is a convenient way to represent the sum of the terms of a finite sequence. So if you can recall the definition of sequence, di ba, it is a patterns. Pag sinabing finite sequence, so we have specific patterns na i-add. So using the sigma notation. So as shown your screen is sample of sigma notation. So we have the value of summation of x sub x where as x sub k where k is equal to 1 up to n. Okay? So we use the uppercase Greek letter na sigma to indicate the sum. Then we can read that the summation of x sub x from k up to n. K na equal kay 1 up to n. So the summation symbol indicates the sum. On the other hand, the argument or the general term, ito yung mismong isa-solve natin. Then, sa baba, may makikita yung lower limit. Kumbaga, dyan mag-start yung ating sequence or series. Then, upper limit kung saan mag-stop yung ating series. For example, you have the sum of the values of x from x sub 1 up to x sub n. So we can have the a sub 1 plus a sub 2 up to a sub n. And the letter k or the lower limit should be less than or equal to n. So dapat lagi mas maliit to, smaller. Then ito yung larger na value. And the letter I, K, or N is our index. Pag sinabi natin index, siya nag-i-indicate kung pang ilang term yung kailangan natin. Okay? So in mathematics, no? So let's have a function of f of I be an expression involving an integer I. The expression f sub fm plus m fm plus 1 plus fm plus 2 up to fn. So, can be compactly written in a sigma notation as written as this. Ayan, summation of f sub I, where summation of fi, where I is equal to m up to n. Okay? So, same lang tayo ng mga definition natin kanina. Nakasulat doon. So, let's expand basic summation of sigma notation. Then, simplify natin siya. So, for example, you have summation of 2i plus 3 from I is equal to 2 up to 4. So, we will just expand this. So, magiging we have the second term na nasa 2 nga. So, maging 2 times 2 plus 3. Then, add natin yung pang-third. So, kailangan kasi natin dumaan ng 2, 3, and 4. So, we have 3 terms. So, kailangan natin yung a sub 2, a sub 3, and a sub 4. then add natin. Pero mas madali kung ililista na lang natin agad, no? So, magiging 2 times 3 plus 3, then plus 2 times 4 plus 3. So, we can have this. So, we can get 2 times 2 is 4 plus 3. We have 7. Plus 2 times 3 is 6 plus 3 is 9. Then 2 times 4 plus 3. So, 8 plus 3 is 11. So, 9 plus 11 is 20 plus 7. Therefore, we can have 27. Okay? Next, for verification, tama yung 27 natin. Letter B, so we have summation of 2 raised to k, where k is equal to 0 up to 5. So we will just substitute the value of 0, 0, 1, 2, 3, 4, 5 sa k natin. So magiging 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3 plus 2 raised to 4 plus 2 raised to 5. So evaluate lang natin, magiging 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, then 2 raised to 5 is 32. So let's add 1 plus 2 is 3, plus 4 is 7, plus 5, 15, plus 16 is 31. 31 plus 32 is 63. Okay? So to check, yes, it is 63. And lastly, so we have the summation of a sub I, where I is equal to 1 up to n. So mapapansin nyo, wala tayong value ni n. So we will just expand this. So pag n-expand natin yan, magiging equal siya sa a sub 1 plus a sub 2 plus a sub 3. Then we have the ellipsis. Then plus a sub n. Okay? Now, let's try naman, i-write natin yung expression natin in sigma notation. So for example, we have 2, 4, 6, 8, 10. So as you can see, it is an even number. So we can have 2 times n, which is mula sa 1 up to 5. Diba? 2 times 5 is 10. 2 times 4 is 8. 2 times 3 is 6. 2 times 2 is 4. And 2 times 1 is 2. Okay? So another thing, paano ko nakuha to? So we can use factoring. So if factor out mo yung mga factors niya, para makita natin ano yung mga similar na constant sa kanya, like 2. Again, let's try this. So in this part, mapapansin nyo, yung denominator ay yung lumalaki sa atin. So we can rewrite this, nangyayari, kung ito yung first term, second term, third term. Kung 1 over 1, still 1. Kung 1 over 2, di ba? Yung 2 natin nanggaling dun sa n neto. So we can conclude that it is summation of 1 over n when n is equal to 1 up to 100. And letter C, so we have negative 1 plus 2, negative 3 plus 4, negative 5 plus 6 minus 7 plus 8 minus 9 plus up to negative 25. So let's have first the first term. So may first term tayo negative 1. Sa second term naman natin naging positive. So anong nangyari? Bakit siya naging positive 2? So let's have factoring muna dito. So we have negative 1 times n. Diba? Kung negative 1 times n yan, negative 1 times 1 is still negative 1. Sulat lang natin na maayos. dito po, pag may negative 1 times n na tayo, may negative 1 times 2 is negative 2. So, kailangan maging positive tong 2. So, dagdagan pa natin siya ng isang negative 1. Diba? May isang negative value pa dapat eh. Okay? Next, pagdating naman sa 3, meron tayong negative 3. So, meron tayong negative 1 times n pa rin. So, dito, nasusunod yon. Diba? Negative 1 times 3 ay negative 3 pa rin. So, ano nangyayari? Kung mapapansin nyo din po, no? Kung naging times na to, so negative 1 raised to 2, which is 2 din yung n natin. Eh kung gagawin ko naman negative 1 raised to 3, which is 3 din yung n natin, we can come up with a constant value na negative 1 raised to n times n. Diba? Pag n natin ay odd, negative pa rin yung makukuha natin yung value. Pag yung n natin ay even, magiging positive na yung value natin. Okay? To check, try natin sa 825. So, magiging negative 1 raised to 25 times 25. 25 is odd, so negative 1 pa rin. Times 25 is still negative 25, which is similar to sa ating sequence. Therefore, for letter C, we have summation of negative 1 raised to n times n from n is equal to 1 up to 25. Okay? So that's end our discussion today. So we just expand and find the values. And in this example 3, we just write a simple series in sigma notation. So for the properties and for the future lesson of sigma notation, kindly wait for our videos.